Uh, Welcome. In this video, I will try to show uh, some aspects of implementing a research paper step by step. So the research paper is in the area of data analytics, machine learning, and artificial intelligence, right? So yeah, step by step implementation. I just thought, okay, while I'm doing it, let me see if I can share some uh, information on it, right? So the research paper is about stock market prediction, actually stock price prediction using graph theory and then uh, graph theory, deep learning, uh, yeah, just uh, in that area. So specifically, my goal is to use some sort of GCN, graph convolutional neural network, one type of graph neural network uh, mm, uh, for the purpose. Okay, let's see. Yeah, I think I'll just say uh, as I go. Share screen. Okay, so this is the research paper that I will try to implement, right? Graph theory, deep learning, machine learning, just stock market price prediction, right? Okay, so if you want to know about the paper, you can check one of our YouTube video or PowerPoint presentation. Yeah, you can definitely uh, read it, right? So let's see. So where do you go, right? So you can see some data set, right? Some data set. So I'm just trying to focus on the coding side implementation. Okay, so there you need a data set, right? Data set, and your goal is prediction of stock market price, stock price, right? Data set. And what data set? They have used Fortune 500 companies, top 30 of them, right? But in my implementation, so far I did not find the exact data set that they are using. So I'll be just we'll take some stock market price data set, right? And then go from there. If I find that data set, then I will uh, apply my implementation on this data set. Yeah, the one of the challenges can be the data set that I will be using and their data set, the format can be slightly different. So I'll need to readjust the data set or the code. Okay, so data set, that is probably one of the important thing that to find out. So yeah, closing day, each day closing price or per minute price. I think they use these two data set. Okay, so data set is one thing, right? Okay. So that's where I start, and I think I also will need to do the graph convolutional network. Graph convolutional network. That's what I need to implement. So in graph convolution network, what I will do, right? Let's say I think at this moment I can give the overview what I want to implement and what are the steps involved. Okay, let's say still I did not plan that much, or what I will say, but still I believe still that will make some sense, right? It's arbitrary, but still it will make sense. So data set thing that I told, and graph convolutional network. And graph convolutional network, there are a couple of ways you can do it. I think Keras, TensorFlow, you can use something from there, and some other libraries like Stellar Graph. I saw there are some others, Sparklet or something else. I think there are a couple of. I think there are some DGI, PyTorch. You will find some. You'll uh, you may need to use some of those from there. I think Network X, that's a graph library, but that is the graph uh, graph mining. So uh, I may not use much deep learning or neural network from there, but I did not see whether even they have it or not, right? So I know that I used networks in the past, some sort of graph mining operations. And graph neural network, I did not check if network X has it or not, but I saw Keras TensorFlow in this domain. There are some, and some other libraries like DGI or Stellar Graph, or I believe I saw something on the PyTorch areas. Yeah, so there will be some libraries there that can do this sort of deep learning graph neural network or graph convolutional neural network. So if you see that I'm wrong, please feel free to let me know. I think as far as I saw, or probably the way I saw and the context that I'm using, or that the context that I'm seeing, there can have some mismatch, but overall the information will be a good point to start, and I believe those are almost correct information. Okay, so yes, so data set, yes, data set, and then graph convolutional neural network. Just feed the data, graph convolutional neural network. It will learn the pattern and using some linear regression. Linear regression means multi-layer perception. It will predict the price, right? It will predict the price. If there will be neural network that is just I think couple of layers of convolutional layers, a couple of layers of convolutional layer. I think on this graph convolutional network, and then a convolutional neural network. I think in this paper they utilize one layer of graph convolutional neural network and another layer of convolutional neural network. Okay, this is one. Then there is another graph convolutional network and another convolutional neural network, right? So data pass, and then eventually a multi-layer perceptron that will do the predicted price. Okay, so these libraries will give you some features so that you can create some layers, right? Graph convolutional layer and convolutional neural network that I think depending on your input, you will need to create those, right? And in this paper recommended multiple sets of layers, right? Graph convolutional CNN. So multiple layers depending of see where you can find the optimum output, right? Optimum prediction or perfect prediction. That's probably what it is. Okay. So let me see. So yeah, that's the goal. I'll take the data set. I'll find a data set, stock market price. I already took something from the Yahoo. So Yahoo Finance, I took some data. I think the formatting was not what I was expecting, but I needed to format. Just what I needed is a day, ticker, symbol of the company, stock, and then the closing price. I think there are some other prices and this and that, but I just tried to take what I need. Even if I feed the same data, all the data, but I probably be selecting the particular field that I need. Okay, set data set, corresponding fields, it matches. Then I will be having this graph convolutional neural network and CNN layer embedded. So some sort of library I will use to create those layers. I will feed. Okay, for feeding, I will need two different sets of input, right? One will be the graph structure. Okay, graph structure because my goal is to convert the stock, convert the individual company stock and their pricing correlations. Depending on that, I will be creating some sort of graph. I think as the paper told, right? As depending on the correlations of the stock market prices, how they go up or go down together, or in different correlations or different directions. So I will formalize that, structure that in a graph. So that will be one input to the graph convolutional neural network, or you can say overall a deep neural network. Okay, that is one thing, right? So far I tried to make, or I was able to make it. So that is one thing. Another thing will be the pricing history, right? Pricing history. I think in the graph that I will be creating from the stock price correlation, that does not have the pricing information. Yeah. I'll be using the correlations among the pricing. I will use that to show, okay, these two stocks are related or these two stocks are related. So some edges. So if there is no correlation between those two stocks, there will not be edge between those between these nodes. So it is just the graph structure that represent the correlation between different stocks. And if there is a real life correlation, means correlation in the data set, then we'll be putting some edge. That's how the graph structure will be created. So it doesn't have the pricing information, but we use the pricing histories and relations of pricing histories among different stocks to create this graph structure. So that is one input. However, we're predicting the price, right? We're predicting the price. So the network that will also need the pricing information. So I'll be putting some array or vector or you can see a matrix. Each column represent the price of one particular stocks, one series historical. So I'll feed, I think for each of the graph node will represent the stock or company, and then for each of the node there will be one time series representing one time series of the historical prices. So for my deep neural network, one input is the graph structure and another input is the historical time series and the pricing information, right? And the output will be the predicted stock market price, stock prices, right? So that will be regression. Eventually, at the end of that, it will be regressed. Okay, so they used RMS prop in the process. Okay, so let's say, so in my implementation, input is graph structure and the time series, deep neural network, and then multi-layer perceptron regression, another regressed output, right? And the data set, from the data set, I will be creating some graph structure. How that graph structure will come from? Because stocks are correlated, depending on that correlation, I will be creating graph. If there is a correlation, there is an edge, right? So that is one thing. And what are the different correlations that I use? I think the Kendall correlations or the Spearman or Pearson, three different graph. I think you can say, so three different graph, I think three different experiment, right? There can have some other variations of the experiment, but you can say for three different graph, at least I can see that there are three different experiment. I will see under these three different criteria, which one performs better. I think graph, depending on different correlations, I'm feeding the deep network and predicted price and see that which one performed better. Okay, I will need to do one more thing. That means I will analyze the financial news, right? I will analyze the financial news, and we'll see that in those financial articles, how those different stock prices are being mentioned, and depending on that, whether multiple stocks are related or not. Will not be very specific about the price or condition up or down. We just want to see whether multiple, if different stocks are mentioned in a particular article. If they mention, that means they are related, and we'll be putting some edge. We will consider, this paper has considered 1 million article. That means in 1 million article, if two stocks are mentioned in an article, they are in an edge with weight 1. If another article mentions it, weight will be 2. So that will be another graph structure. And then let's say again another input will be the historical price for that corresponding stock, the historical price. Another input to the graph neural network. What I mean, let's say graph neural network input graph structure, but this graph structure will come from financial news mentions, graph structure created from there. But we still need to feed the pricing information. Otherwise, where we will predict it from, right? So another time series for each node, or probably in a matrix form, into the graph neural network. So okay, so far, yes, I could create some sort of correlations and those matrices. I think the graph structure. So far, I created the correlation based, not the financial news based, and also the structure. Sorry, historical price information related matrix. That's so far I made, and I'm working on the graph convolution neural network layers, figuring out what will be a good combination of the different layers. So okay, so after that thing matches, I can figure it out, and then if I can feed this there and make it work and regressions, then it will proceed from there. Okay, so what else? So I was also telling that I'll be predicting, right? Predicting from the data set. So I need to test it, right? I need to test. So I need some training data set and testing data set, right? Training and testing data set. So in that case, okay, in that case, I think usually what happens in time series or stock market, we selected a period for the, training, right? We just don't divide the data. Let's say there is a big table. We just don't say, okay, this is training and this is testing. You can do this provided those are sorted in timestamp and increasing, or you can separate it out. Okay, in general, let's say for 1 year, we can say, okay, for 10-month prices, we'll be taking this as a training, and then another 2 month that will be for the testing. Usually, it probably is better to take multiple years, and because it's not always possible that okay, I think not go to in the direction of whether prediction, what prediction is good, what prediction is not good. That probably is the domain of the financial experts. And let me see. Let me not go there yet. Okay, so whether this thing get justified the prediction in real life or not, or whether they become useful or not, that probably is a different case. Let's just focus on the implementation part, right? What else? Okay, so let me say this paper may be copyrighted. I shared a little bit. I'm not sure. I probably did not share a lot of that. So I believe a preview will not hurt that much, and it might even be a publicly available paper. So, okay. So far it is, okay. Let me go. Okay, let's not go to another thing. Okay, I will repeat whatever I said so far. I will repeat those. Okay, I'm still here. I'm just trying to see. Okay, I'm sharing my YouTube channel. So this is the YouTube channel. So I'm coming out because I shared some slides. So if you watch the slides, and then you will know what this paper is about. I did not share about the implementation yet. Okay, let's see. So in terms of implementation, so what will be the step, right? What will be the step? Let's say, first of all, I need to load the data, right? I need to find the data. As I told, I found the data. And then I need to load the data. I'll be using Jupyter Notebook Python for the most part. So after loading the data, okay, let's say before even if I go this far, I need to adjust the data so that I can use it. I think the primary thing that I need in the data is the sticker and the corresponding closing price, daily closing price for the main thing that I am doing, right? For the main thing, and there is the per minute price. Let's go to that later. Okay, so load the data and then find out the correlations between these stocks using some Pearson, Spearman, and the Ken delta correlations, and then see if the correlation is if greater than 0.5. If it is, then I create a graph with edges for Pearson, Spearman 0.4. If the threshold is correlation is greater than 0.4, then I create edge and the corresponding graph. If the correlation is more than 0.3, then another graph using Ken delta, right? This correlations and the graph. So that will be the thing, right? Okay, so the graphs are there, and then I also need to see the. I will also need to create the time series related matrix, right? For the selected, for all of the selected stocks, I need to find out the corresponding time series. I think it's in the data set. I'll be taking and reading some matrix. I think so far I could go there, and then I told that after this is there, then we need to create the layers, right? Graph convolutional layer, CNN layer, so that we can feed our input data there. So I'm working on it. So that's where things are. So layering part. Okay. Okay, then I can go to the coding part. Okay, yeah, different experimental designs. I need to do a different experimental design. I think different setups like graph convolutional network with Pearson correlations and the corresponding prediction step price. That is one. Then the graph convolutional neural network and the Spearman correlation related graph and the corresponding pricing and the prediction. So there are multiple different experimental design for this step prediction and see which one works better, right? And this paper has done something more. They used some linear regression for the prediction. And for the linear regression, they also used some Lowian community detection to identify the communities, and then they used utilize those communities for the stock market prediction. I think on a related note, in the past, I actually implemented Lowian community detection algorithm in the past using graph. I think some big graph, I identified the different communities using that algorithm. I implemented in Python and Spark. I think it is the PySpark. That's where I implemented, but I may or may not go that far, depending. And I may not use that same implementation. I may just try to use some library function. Even if I go there, that I create some. I think the graph that we created based on the correlation or financial news information, I may apply that Lowian modularity algorithm to create communities, right? And then from there, use linear regression to predict prices utilizing this communities. I may or may not go there. Okay. This paper has done this. And this paper has done one another thing, ARIMA, right? ARIMA, the traditional statistical method to predict stock prices. This paper has implemented that. And for me, I do not want to implement it ARIMA on my own, but I may try to see whatever output I get, and if I can take a third-party ARIMA implementation and say for the same stock market and for the same data, what prediction they can make. I can take the entire data, or I can just say some sample stock price. And if there is an option to give some data or some duration and matching duration, my data set and that data set, that matching duration, and see what is the prediction they can do and what is my model prediction does. I will compare. Implementing ARIMA is not my goal yet. That's the GCN and the different graphs, including financial news, prediction. That's what I will see, and I will see because I will also the test data, so I will know whether my implementation work well or not. The test accuracy that will define whether my thing work well or not. Okay. Okay, I believe it shows the GitHub. I plan to keep the code here. I will be implementing Jupyter Notebook, but I will be keeping the code here. So yeah, it's under. Okay, it's my MacMaster account. I think I have GitHub in Ryerson account, my personal account. Let's keep it under the MacMaster thing. Okay, I just created the repository right now. There is nothing into it. Okay. So let me pause and try to update some data. Yeah, I think it's time for a another video, but let's see, just it makes sense, or this repository is for this project So make some reductions. Okay, so I'll upload some data here. Okay, let me see. I think one of the common practice that you create some, you keep your data in some data folder, right? Let's try that. So data. Okay. I think this is one way of creating a folder. Now I will upload the data set. Okay, so data set folder, it has, okay. Okay, the data itself is not that big. Let me see. It probably looks like 7 megabyte. Okay, because I'm trying to see how much do I upload at this point. Okay, I will be uploading one of the merged data set. So you can see the data here. Okay, you will need to download it. Okay, I believe I can stop here and I can go to the coding part next.